Welcome to the fifth part of thermal properties of matter. Heat capacity. The quantity of heat required to warm a given substance depends on its mass and the change in temperature and on the nature of the substance. The change in temperature of a substance when a given quantity of heat is absorbed or rejected by it is characterized by a quantity called heat capacity of that substance. Mathematically, heat capacity S is equals to delta Q divided by delta T. Here delta Q is the amount of heat supplied to the substance to change its temperature from T to T plus delta T. If equal amount of heat is added to equal masses of different substances, the resulting temperature changes will not be the same. That means every substance has a unique value for the amount of heat absorbed or rejected to change the temperature of unit mass of it by 1 unit. And this quantity is known as specific heat capacity of the substance. If delta Q amount of heat is absorbed or rejected by the substance of mass m when it undergoes a temperature change of delta T, then the specific heat capacity denoted by small s will be capital S divided by m, and you know the value of capital S is delta Q by delta T, where delta Q is the amount of heat absorbed or rejected, m is the mass, and delta T is the change in temperature. The specific heat capacity is a property of the substance which determines the change in the temperature of the substance when a given amount of heat is absorbed or rejected by the substance, and it is defined as the amount of heat per unit mass absorbed or rejected by the substance to change its temperature by 1 unit. It depends on the nature of substance and its temperature. Its SI unit is joule per Kelvin per kilogram. If the amount of substance is specified in the terms of moles denoted by mu, or in some books it is denoted by N, then instead of mass m in kilogram, we will define heat capacity per mole of the substance, and that will be capital S divided by number of moles, mu. Here C is known as molar specific heat capacity. Like S, C also depends on the nature of the substance and its temperature, and its SI unit will be joule per Kelvin per mole. However, in connection with specific heat capacity of gases, additional conditions may be needed to define this molar specific heat capacity. As if the gas is held under constant pressure during the heat transfer, then it will be called as molar specific heat capacity at constant pressure, and it will be denoted by C with a subscript P. On the other hand, if the volume of the gas will be constant, then it will be called as molar specific heat capacity at constant volume, and it will be denoted by C with a subscript V. Water has the highest specific heat capacity compared to other substances, and for this reason it is used as a coolant in automobile radiators as well as a heater in hot water bags. Due to its high specific heat capacity, water warms up much more slowly than the land during summer, and consequently wind from the sea has a cooling effect. Calorimetry. The branch of physics that deals with the measurement of heat is called calorimetry. Principle of calorimetry, or you can say the law of mixtures, is whenever two bodies at different temperatures are placed in contact with one another, heat flows from body at higher temperature to the body at lower temperature till the body acquire the same temperature. And the principle of calorimetry states that the heat gained by the cold body must be equal to heat lost by the hot body, provided there is no exchange of heat within the surroundings. Means heat gain is equal to heat loss. This principle is a consequence of the law of conservation of energy and is useful for solving the problems of calorimetry.